There are two basic ways a computer can search. One is called the linear search, and then the other is the binary search. Now, linear means go one after the other, just side by side, in a linear fashion, in a sequential fashion. So that is one of the ways. The other way is binary search. Now, binary not in terms of zeros or ones, what you understand in the memory and the hard disk, but binary in terms of splitting in terms of two. Now, the thing is, in binary search, you're supposed to have the element or the sorted array or the data set in order, in alphabetical order or in ascending order. It should be arranged beforehand. So what we should do is let's think about these two with a program example. So over here I have two C++ files. One I have a linear search.cpp, the other I have binary search.cpp. The linear search.cpp is code is basically is going to find X in an array. So let me just make this dark. All right, so suppose I have an array. So I have an array and I have a size to it. So I would say, so I have, it starts from 0. It's always 0 indexed. 2, 3, 4, and 5. Now this is a very small data set, right? Now there are going to be tons of data sets, but we're going to talk on grassroots level. So this is starting from 0, ends till 5, and you want to search through it. One way is to do linear search, and linear search is basically like this. Go from one element to the other, to the other, to the other, to the other, to the other. And remember, these are not the elements, these are just the addresses. Now the element, I could say, for instance, this element should be something like that. Something like, for instance, this has A, this has B, this has C, D, E, and F. Now please forgive my writing. I suck at this, I know that. Okay, so we want to find E. Now in linear search, it's basically going to start from the very beginning and going to go all the way, so B, C, D. Once it finds it, it's going to return from the array and gives us the required result. And when we think about larger data sets where there's tons of code and when the data set extremely becomes bigger and bigger, this is not a good approach. And this is going to become very, very slow. So for that, we have binary search. And binary search is basically creating a sorted array. For first of all, you have your array sorted out. So in my particular case, it was sorted. But in so many cases that it won't be sorted, you'll need sorting algorithms to first essentially sort the data set into an ordered sequence, and then after that you could apply binary search. And this is really fast. So for instance, we have A, B, C, D, E, F, A, B, C, D, E, F, all right? So this is the elements. So I would say this is the address, 1, 0, 1, 2, 3, 4, 5. And these are the elements inside of these arrays. So if I want to access, for instance, the D element, what I would do is basically do binary search. Now binary search, what I could do is basically have an element and it could split it into two. So it would go in the middle and you would see that there's 0, 1, 2, and 3, 4, 5. So it would split the middle right here. And it would say that the number you're looking for, like for instance, I say I'm looking for E. Now you think it's sorted, right? So it will check. So is a C, and it checks the left side, and it says if that E is greater than the left side, and if it is, so if E is greater than the left side, so it's just gonna ignore this part and it's gonna move to this location. And over here it would split this into two and a half, so it's going to be in the middle section, and it's going to check over here. So it's going to say if E is greater than C. So if it's less than, it's going to remain in this section and it's going to search over here. And then if it's not, it's going to go and ignore this as well, and then go over here and try binary search through that. So we have another binary search here, and it goes and checks the D. Well, D is not. So then it goes and one step forward and says E, okay, that is. So you could see how easy that went, and it was a lesser amount of steps that were taken as compared to the linear search fashion, which goes one at a time. And this, the algorithm for this has a log of n, which is the notation O log of n. This is the O log of n, and it's much more simpler than O of n squared. And this is basically very long. For our linear search is O of n. So you can see that this is much faster than this. And this is linear fashion, and this is much faster. So this is binary search. So now let's go in our code and let's understand what we wrote up. So over here in my IDE, I have a linear search folder. I would say a linear search file. Inside of it, it says basically it has these 3 header files included: iostream, ctime, use first time, and I wanted to note down the time, so I use the ctime. C standard library is also used for additional functions. So using namespace standard, I have this function defined over here. It's a search function. It gets an array and it gets the number. What you want to, basically it wants to get the size. So this is the array. It gets the size of the array and gets the number that you want to look for inside the array. And now note this is in the linear search, so the order doesn't matter. It doesn't have to be arranged in a sequence. So it could be randomized and it would just go one at a time. It doesn't matter in the sequence. So it says int I, and then after that it will go in a for loop, and you will see that it's going from 0 and it goes till the size of the array, and then increments by, would say, +1. And then after that, if the array sub I matches the number that you're looking for, you return the number, right? And if you can't find the number in the array, we just return -1. So that's really simple. Driver code over here is in main void. We have a time variable, so this is what was used using the ctime and C standard library. We have time underscore t, and we have t1 and t2 as the time. Static random time 0, which we set the clock of the computer. Int array, we have just a random array, and this is in a sequence. So you could see that I have this array in my stack. Now you could have stored in the heap. You could also get some external file and search through that. But in this particular case, we just have it in the stack. So basically x is equal to 10 is the number that we're looking for. You can see over here that it's in the, I would say, 3rd index, because it starts from 0, 1, 2, 3. So what happens is that we want to find the size. So we could do is size of array, which is size of the array. Total array is 1, 2, 3, 4, 5. 5 multiplied by 4, which is 20, divided by size of array sub 0. So this is the first index. And you could do any kind of index because every is going to be 4. So basically it's going to be 4. So size of array, which is 20 divided by 4, and it gives you the element, which is 5. So this is the size of the array, 1, 2, 3, 4, 5. And then after that, we have a time ampersand time 1. This is where the time starts. And then I stop the time over here in the ampersand 2 signal. Over here inside of it, it has an integer result, and it calls this function search. The search function that we already discussed is just going to look through the loop. It's going to loop through the array, and it's going to find. If it finds it, it returns the number. If it doesn't find it, it just gives a -1. And then this time will be noting down the time. Over here is very special. This I haven't addressed in any of my videos. This is called a ternary operator. So what a ternary operator is, it's just like an if-else statement. You could do this with if-else or if you want, but this is really in like a single line. And I actually scattered it into 3 lines, but it could be represented in a single line format. So you don't have to actually have these in separate lines, but to address it, I would just show you that how it looks like in a single line format. So what we have is that we have a condition here. Now the condition is result is equal to -1. So if it's true, right, that means that the element is not present in the array. If that happens, this condition is implemented. So cout after the question mark will be implemented. So this is cout element is not present in array. So after the colon is the false condition. So if it was present, it's going to print out element is present at index, and it's going to tell the result. So the result will be the index where it is present. So we could see that element is present, and it would return the x of it. So that was that with all of that. So then after that, you could actually have it like this, or you could just have it in separate lines, and I think it looks more presentable like through this. So I would just keep it like that. I have a carriage return right here just to make the format more prettier. We have a double sort time, and this is another variable that I created. What I did was basically get the time of 2, which was the last time, right, which stopped. I used the function call here, and I just wanted to measure the time it took to basically get my element. And so I did is time 2 minus time 1. When I get the resultant value, I put in the sort time, and I did is time taken by sort array, and then I got the sort time, which is the total time it took in seconds. So this is going to be like that. So for instance, let's run this code and let's see how it would work. So I have the index, and let's see how much, and of course it won't take that long. So if I run this code, you see in the output screen that it says element is present at index 3 and time taken by sort array 0 seconds. The reason behind this is that it's not a big data type. Once you enter into logical, when you enter the big data sets and when you get more and more higher with the complexity, then you would have a large amount of portions of data, and that would take generally more longer speeds. So you have a binary search, which is the next thing that we have to look, and this is basically mostly similar to it, but the process, what I was told, that it basically reduces the steps. Now you don't basically necessarily have to go from the first element to the end element, or from the n squared. You don't have to do O of n in this, and you basically reduce it to log n. So what is basically over here is ACK, hash include iostream, ctime, and cstandard library, which are over here. And then we have using namespace standard. We have an int search, we have an array, and we have an int n and int x. So now a really important thing here is that I just wanted to address is that inside of this function we have another function, and this is basically calling it. So what we could say is that this is called a wrapper function, and the function inside of it is called an auxiliary function, also known as a helper function. So this thing inside is called a wrapper function, and you could just say over here. And then inside of it, so right here, is the helper function, or the auxiliary function. And again, I would say that this is mostly used in recursive calls when you have the same particular function with the same identifier, but the arguments change. So auxiliary and helper functions would be more suitable for that particular example. But in this particular example, I would say, yeah, okay, roughly speaking, I would say, to make you guys understand, you could say this as a helper function. So what happens is that this binary search iteration, it has an array. So we pass an array, we pass in the size of the array, we pass in the element that we want to search. So we pass in the array, we pass in 0. Now this is, I think, the starting index. Now n-1 is the last element in the array. Because the n is the size, so n-1 will be the last. X is the element to be searched. So what we do is iterative binary search function. It returns the location of X in given array. So it goes from L all the way to R. Now R is going to be the last element, and L is going to be the first element, 0 indexed. So if present, otherwise it will return -1, just like what we did with linear search. So in binary search iteration has this 4 arguments, and they're pretty similar. Just look at them and compare over here, array, and then we have a first index, which is I would just say starting, and then we'd say n-1, which is the range, I would say the last element, and then X is the element to first search for. Now over here we have while L is less than equal to R. Now it says that if the index just started from the beginning. So this in conclusion means that it has to be sorted. So we're finding a midpoint, just like we did with this example here. We had to find a midpoint over here. So what we did is basically have that array sorted. We got the first element, plus we have this in parentheses. So this is the last element -1, and then it would divide it by 2. This is a particular formula. We'll take out the midpoint of the array, and then check if X is present at mid. So if it is present, so we'd say we got that element in the mid point. So if it is present inside, just return that element from the mid. But if it's not present, so it would just return M, which is the midpoint array, right? So if X is greater, ignore left half. So if X is greater, just like we did over here, if it was greater, we just ignored this left half and went into this next portion over here. So we ignore if X is greater, we ignore it and we say M+1, which is midpoint +1, and that would be the left. So if X is smaller, ignore right half. So we'd say M-1, which would say that the midpoint lesser than the midpoint. So if I could go over here, you would see that this would be ignored, and then the control would transfer here, and it would check over here midpoint and all of that, and you could see that the R is over here instead of the L. L is going to be for the right, and then the left one, when you're actually ignoring the right portion, will be with the R, which is the last element. So if we reach here, then element was not present. So if it all terminates, this while loop is just going to go on until it finds it. But if it doesn't find it, it would return -1, indicating that there wasn't that specific element in the array. So what we're going to do is basically int main void. We have a time underscore t. We have t1 and t2 as 2 variables that are associated with the time variable, time underscore t. The static random, we notched it up by just setting it to 0. And we have an array which has 2, 3, 4, 10, and 40. and what we need is 10. So we know that this is in the index 3, and the size of it, and just like the previous one, what we did is we call this function and put in the time. We did this ternary operator, really like this approach, and then we have to subtract the 2 and get the time noted out. So if I run this code, you would definitely see similar outputs as compared to the first one. You see over here that there's binary iterator not declared in the scope, binary search iteration. So we have an issue over here that in line number 13, return binary search iteration was not declared. So let's just look at line number 13. And over here it says binary search iteration is not declared. It's because that this function is being called and it's read before. So when the compiler reads the code, it goes line by line. And when it went over here, binary search iteration, you called it, so it doesn't understand what it is. So you should have a prototype to it defined. So I get this prototype. So I just copy this prototype, and I just declare it before it. So I actually gave a signature over here, and now that the compiler knows that this is actually defined, and it's a good practice to have both of the prototypes defined over here. So I'm just gonna put this one as well, and then we could move forward. So let me just run this code once more, and I'm hoping that it would work properly now. And there you go. We have element is present at index 3, time taken by sort array was 0 seconds. If you guys like this video, make sure to subscribe to the channel. If you want more complex videos and want more examples related to binary and linear search, we do have one version. I was thinking of recursion, because this is done with iteration. So binary search can also be done through recursion. So if you wouldn't like that, or you would like more additional videos, please let me know in the comment sections. I'll be reading all your comments out. And thanks for supporting, and see you guys in the next video. Peace out.